Hi, welcome to our math. Today I'm doing a series of videos on exponential models and linear models. But before I get into the application problem, I just want to do a quick video on, if you just have a table of values, how you can tell if it's linear or exponential and how to find the model in either case. So for my first example, I have a table of values and I always test linear first. I find that linear is faster. So when I find linear, I usually do an in-table shortcut. I ask myself, what do I add or subtract to move forward? So in this case, I would be adding 1.25. And then I check the next one. And again, I'm adding 1.25. This is looking good for linear. My next one is still 1.25, and my last one. Now I have to look at my output compared to my input. And my input is going up by 1 at each step, so that my slope is output divided by input. So in each case, it's 1.25. So I do have a linear equation. I've tested it out. It works. Everything is linear. So then my model, y equals mx plus b, I do have b given right there. I always look for the intercept. It is often given, and if it is, use it. I also note what variables I'm asked to use. So f of x equals 1.25x plus 0.25. You could flip that around to 0.25 plus 1.25x. It's not standard. It kind of makes more sense though, where you start and how you move forward. For my second example, once again, my input is going up at a steady 1 by 1 step. So now I just need to look at my output. Once again, I'm going to test linear first. This, I would add 0.08. And here I would add 0.12. And this is really not looking good. So if this was a scatter plot, it would be potentially representable with a line, but we're not doing a scatter plot. We're not doing an application here. Right now we are looking at pure math world. And so if this were to be linear, each of those would have to be the same. Okay, so they're not linear. So next we test for exponential, and what we're testing for exponential is we're looking for a single multiplication factor that moves us forward. So what I'm going to start off with, and we're just looking at the output, 0.16 times a, my multiplication factor, is equal to 0.24. Okay, if I divide both sides by 0.16, I get that a is equal to 1.5. Now I need to test them all. I could test them by pulling out my calculator and just saying 0.16 times 1.5, 0.24 times 1.5. It's a faster method. I'm going to just do the brute force. I'm going to say 0.24a equals 0.136, divide, a is equal to 1.5. 0.36a equals 0.54, a is equal to 1.5, and 0.54a equals 0.81. And now you're saying, well, why did you do them all? Obviously, it's going to be exponential. And the reason is, in my directions on this, I said they're going to be linear or exponential. But oftentimes the directions say linear, exponential, or neither. And if it's neither, you really do need to check them all, because what's going to happen is a stealthy instructor is going to make the third or fourth one different. And so you need to test all of them, because as soon as one doesn't fit the mold, you don't have a model. Okay, so once again, I now have my multiplication factor. I also have my starting point, 0. So for an exponential, the generic is f of x equals c a to the x, where c is your initial value, your y-intercept, what f of x equals when x is 0, and a is what we just calculated. But I have to use the variables given. So I'm going to say h of t equals 0.16 times 1.5 to the t. Now remember, that variable and that variable have to be the same. All right, there's two more examples. For my next example, this is going up by 1, this is going up by 3, this is going up by 2, this is going up by 1. I'm going to test linear. Minus 50 over 1 is 50. Minus 98 over 3 is about 32.7. This isn't going to be linear. All right, so what's happening here is if we looked at our table, -3, -2, 1, we really have to say -1, 0, 1 to see what's going on. If this is 250 and this is 200, then I can say 250 times A equals 200, and I divide that out to be 0.8. But for this one, I have 102 here, which means I need to multiply by A, I need to multiply by A, I need to multiply by A. In other words, I multiply by A 3 times. So I have 200 times A cubed equals 102. When I divide this out, I get that A cubed is equal to 0.51. Now don't clear that out of your calculator. Just find the 1/3 exponent or the cubed root, same thing, to get that A equals, well, I get 0.79, but I'm just going to round that to 0.8. With multiplying, you have to do a little bit of rounding. All right, for my next one, there are 2 A's, so 102A squared equals 65. So that A squared equals 0.637. And when I square root this one, I get that A is equal to, once again, it's going to be 0.79, blah, 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 which we round to 0.8. And for my last one, there's only one A, so 65A equals 52, and A equals 0.8. All right, so we're good. Variables, oh, we don't have our 0. Okay, so we know that C of M equals some initial, sorry about the double C's, times 0.8 to the M. I'm just going to use an ordered pair. I'm going to say 250 equals my unknown times 0.8 to the -3. I put 250 in for my output. I put -3 in for my input. I can now divide both sides by 0.8 to the -3. And I get that C is equal to 128. So now I'm done. I have everything I need. I have to remember to put it together. C of M equals 128 times 0.8 to the M. All right, for my next one, I have +3, +4, +5, +6. Minus 75. 75 divided by 3 is -25. Minus 100 divided by 4 is -25. Minus 125, -125 divided by 5 is -25, and minus 150. -150 divided by 6 is -25. But I have to figure out what 0 is. I'm going to do a tricky method where if I extended my table, -2, 500, -1, 0, 1, 425, if I'm subtracting 25, why not subtract 25? 475, 450, 425. There's other ways, and I have lots of videos on how to do it in other ways with linears, but since the slope was so simple, go to my variables, g of h equals -25h plus 450. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.